right, now our last section with inequalities is going to be absolute value inequalities. So remember, with absolute value signs, any number that's inside will come out to be a positive number. So in these absolute value signs, we could either have a positive 5 to give us this 5, or it could be a negative 5. Same thing here. Inside the absolute value bars, they're going to drop and automatically become positive. So this could be a positive 8, or it could be a negative 8. And so what that means is we have to set up and solve two separate inequalities. So absolute value inequalities are actually going to be compound inequalities. And sometimes it'll be and, sometimes it'll be or. Less than inequalities will always be an and inequality. And the way that I remembered this from school was my teacher taught us that it's less than. So a less than sign will make an and inequality, and a greater than sign will make it an or inequality because we're doing a great or. So what that means for this first one, since this is a greater than inequality, this is going to be or. So that means that x can be greater than or equal to 5, or, and then what we do is we flip the sign. So x could be less than or equal to negative 5. When we graph it, we go to our negative 5. I want x to be less than, so we're going left, so any of those numbers will work. Or we go to our positive, any of those numbers will work. Interval notation, it's from negative infinity to negative 5. Bracket because it's included, or we start again at positive 5, we go to positive infinity. So any number basically other than what's not shaded in is a solution to this inequality. For the next example, since it's a less than, that's going to be an and inequality. So negative 8 is going to be less than or equal to x, which is less than or equal to 8. We go to our negative 8, fill it in. We go to our positive 8, fill it in. And then everything in between is a solution. So our interval notation, negative 8 to positive 8, both get brackets. When we're solving these inequalities, we have to set up the two separate problems. So we keep the first one. All right, here I had x is greater than 5. We keep it x is greater than 5. For the second one, we switched the sign, so we flipped it to less than, and then we flipped our sign to from positive 5 to negative. Here we technically did the same thing. All right, our first one, x is less than 8, stayed the same. But then when we flip it, now we have x is greater than negative 8. So technically we did that, we just didn't show it because this is an and inequality. We ended up reversing our sign anyway to keep that x in the middle. We solve both inequalities, we graph and write our answers in interval notation. All right, so 1 and 2 are the same kind of thing we just did up above. So try those out real quick. I'll move back up so you can see those examples. So try out 1, try out 2, see how you do. All right, so for number 1, it would be an and inequality. We're going from negative 7 to positive 7. They're not included, so we use parentheses. Number 2, since it's greater than, that would be an or inequality. So either x is less than or equal to negative 4, because we have to flip our sign, or our other inequality, we just leave it the same. X is greater than or equal to 4, and we set up our two separate intervals. So now when we have stuff inside the inequality sign, we're still going to set up the two inequalities and then we solve them separately. So for the first one, just like with equations, we leave it alone. X minus 1, I leave my sign, and I leave my number. Add 1 to both sides, we get that x is greater than 7. But this is an OR inequality. So now I have to set up that second one. We don't do anything on the left, so I leave it x minus 1, that stays the same. But now I flip my sign, I make it less than, and I turn my 6 negative. So now when I add 1 to both sides, I have x is less than negative 5. All right, so when we go to graph that, we go to our 7, not filled in. We're going to go to the right. There's one part of this absolute value inequality. Or I go to my negative 5, and I go to the left. All right, so just like when we did equations, sometimes the numbers are the same, but one's positive, one's negative. Sometimes they are totally different. Interval notation, start with our smallest, so that's on the left side, negative infinity to negative 5, not included. And then we skip over to the next part, we pick it back up at 7, and then it goes to positive infinity. All right, so we're going to do the same exact thing with number 4. For the first part, we don't have to change anything about our inequality. We're just going to leave it as x plus 2 is less than or equal to 7. And then we solve our inequality. So I subtract my 2 from both sides. I get that x is less than or equal to 5. Now this time it's a less than sign, which means it's and. So we'll end up with shading in between the two pieces. X plus 2, we don't change that. But now we flip our sign, so make it greater than or equal to negative 7. And now when I subtract my 2 from both sides, I have x is greater than or equal to negative 9. So that part of the graph would go to the right. This part would start at 5 and go to the left. And so our solution is only what's in between. So starting at negative 9, fill it in. Goes all the way to 5. And the solution is everything in between. So for my interval notation, negative 9 is my smallest number, it's included. 5 is my largest, it's also included. Try out number 5, see how you do. All right, so here's your two solutions. First one we leave alone, 2x plus 5 is greater than 3. We would go through and solve, we get x is greater than negative 1. Because this is a greater than, it's going to be an OR inequality. Leave the left side alone, so 2x plus 5, but now we flip the sign, make the 3 negative, and again we solve. Now just like with our equations, we can't solve the inequality until we get rid of all the stuff that's outside of the absolute value. So for this first one, I can't do anything yet till we get rid of this minus 1. I would start by adding 1 to both sides. And so now when we set up our two inequalities, our first one will be x plus 3 is less than 6, and then 6 is the number we use, not 5. It's a less than, which means this is going to be an and inequality. So you could set this up differently, and I'll show you how. Again, we're going to leave this x plus 3, but now we flip our sign, we make it greater than negative 6. So if you wanted to write this differently so that you're not doing quite as much work, because it's less than, I know it'll be an and inequality. I can write it out like this. Negative 6 is less than x plus 3, which is less than 6. And so now when I solve it, instead of adding 3 here and 3 here, I can just, subtracting, we can just do that from the middle and the left and the right. Doesn't really matter, you'll get the same answer either way. So when I subtract 3 here, I get negative 9 is less than x, which is less than, and then 6 minus 3 will give me 3. So this is my and inequality. I get the same thing up above. So here, if I subtracted 3, I would get x is less than 3. Same thing we got right here. And then on this side, if I subtracted 3, I would get x is greater than negative 9, which is the same thing we got here. This is just condensing it a little bit. So remember, since this is an and inequality, we include what is in between the numbers, nothing on the outside. So negative 9 is our smallest value, 3 is our largest value, and we're going in between those. Parentheses because it's not filled in. So from negative 9 to positive 3. All right, same idea with number 7. I can't do anything till we get rid of this 3. So we're going to start by dividing. And then 30 is not what we use to set up our two inequalities. We're going to use 10. So now when we set those up, leave my first one alone. So 2x plus 8 is greater than or equal to 10. Oopsies. My goodness. Sorry about that. And then because this is a greater than, this is going to be an or inequality. So then our second one, we do 2x plus 8, flip it to less than or equal to, make it negative 10. Now we'll go ahead and solve. So from each inequality, we start by subtracting 8. So minus 8 here. All right, same thing here, minus 8, minus 8. So now we have 2x is greater than or equal to 2. Here we have 2x is less than or equal to negative 18. So then our final solution would be x is greater than or equal to 1, or x is less than or equal to negative 9. So my arrows should point away from each other, and then we can go ahead and graph it. I go to 1 here, it is included. We go to the right. I go to negative 9 here, it's included. We go to the left, and then we do our intervals. So since we're at these infinities, I need parentheses around the negative infinity. That first one's going to stop at negative 9, and it's included, so it gets the bracket. We pick it back up again at 1, and then it goes to positive infinity, and it gets the parentheses. All right, now same thing with number 8. We start by multiplying both sides by negative 2. So that's going to do a couple of things. It's going to get rid of that division. So now I have absolute value 4x minus 8. But now when we go to solve, because we multiplied by a negative, I'm going to flip my sign. So now it becomes greater than 12. And then since this is a greater than inequality, we set our 2 up, and it will be an or inequality. So first part, 4x minus 8 is greater than or equal to 12. We don't do anything other than drop the inequality, or I'm sorry, drop the absolute value bars. Or 4x minus 8 is less than or equal to negative 12. And then we solve the two inequalities. So start by adding 8 everywhere. Now I have here 4x less than or equal to 20. Over here we have 4x less than or equal to negative 4. And then when we divide everything by 4, we get our two answers. So x is greater than or equal to 5, or x is less than or equal to negative 1.